Hello and welcome to 12.4 day 2. This one is so pickin' cool. You are going to love this. This is called chord. W, X, Y, and Z. Did you know that W times X is always the same as Y times Z? What? It's true. It's true. So let's say I had something like this and like this, and I was like, ooh, that's a 3 and that's a 6. This is the length we're talking about, the length of it, not like the angle. This is weird. These are chord lengths or segment lengths. And if I called that guy like a 2 right there and be like, hey, what's that? Well, you're like, well, if it's true that this times this is this times this, look at that. That's so simple. 3 times 6 is 2 times what? 3 times 6 is 2 times what? Well, 3 times 6 is 2 times what? Well, that's 18, and 18 is 2 times 9. 9. Whoop, whoop. Done. That's it. Let's do another one. All right, so what about blah, 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 blah. Okay, and this is like a 3, and this is like a X, and this is like a 2, and this is like a... Just kidding. This is like a 4, and this is like a 6. Okay. So 3 times what is 4 times 6? 4 times 6 is 24. 3 times what is 24? 8. You don't have to write it down. 3 times X is 4 times 6. 3X is 24. Looks to me like X is 8. Now that is really cool. Chord. Very simple. Now it gets a little bit spicier now. Because now, so that's the chord rule. Chord. It's not fun to do. It's not only fun to do, it's fun to say. Chord. This one's called secant. And a secant. All you gotta do, there's an outside part and an inside part. And there's an outside part, and there's an inside part. So the outside part times the whole thing is equal to the outside part times the whole thing. So it's like the exterior part of the secant times the entire secant. Now this is a little bit weird, so I need to show you a couple of these. All I'm going to do first is show you one that actually works really well. Okay. Now this isn't going to look right proportionally, but if that's a 4 and that's a 5 and that's a 3 and that's a 9. Sorry, my picture's a little off, but this is how this works. Now 4 times 5 isn't 3 times 9. That's not what we're doing. But isn't 4 times 9 the same as 3 times 12? 4 times 9 is 3 times 12. 4 times 9 is 36. 3 times 12 is 36. So outside times the whole equals outside times the whole. So let's say I gave you something like blah, 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 zoop. And this is a 5, and this is a 3, and this is a X, and this is a 4. You're like 3 times 8. 3 times 8. 3 times 8 is 4 times... 3 times 8 is 4 times what? Well, 3 times 8... 3 times 8... Well, 3 times 8 is 24. Well, 4 times... So you can go like 3 times 8 is 4 times... Now, some people just do this, like 4 times what? The whole thing? If you feel like doing 4 times 4 plus X... I'll show you some algebra in a second. I'll do an alternate version in a second. So 3 times 8 is 4 times what? Well, 3 times 8 is 24, and 24 is 4 times 6. And if this is going to be 6, if this whole thing is going to be 6, this inside here has to be 2. So your answer is 2. Outside times the whole, outside times the whole. Now people say, well, that's a little too much in my head. I want to go 3 times 8. 3 times 8 equals 4 times 4 plus X. Nothing wrong with this at all, because now 24 equals little distributive property. 16 plus 4x, subtract your 16 off both sides, and what do you know? X equals 2. Very nice. Secant. The last one is called secant tangent. And this one's kind of cool / weird. I wish I would have been the one to figure this out. So if you have a tangent portion and a secant portion, and this is called W. I'm using the same letters that are on your worksheet, and that's why in that Z, the outside squared is equal to the outside times the whole thing. Isn't that cool? So the tangent part squared equals this times the whole thing. So if they give you something like, I'm going to show you this a couple different ways. Like, let's say that's a 2 and that's like a 6, and this is like x. Well, that means that x, the outside squared, is equal to 2 times the whole thing. Now, very, very commonly people do 2 times 6 by accident, but the whole entire thing, the y plus z, the whole thing. So x squared equals 16, so x obviously equals 4. Well, there you go. Outside squared equals outside times the whole thing. Things could get a little bit different if it's given to you that it's like something like this, and they give you the outside, and they give you the outside, and they tell you the inside. They're like, well, that means 10 squared equals 5 times the whole thing. Now, here's where I think you should adopt this idea, where 10 squared, 100, equals 5 times the whole thing. And it's gonna be 20, right? Because 5 times 20. So if the whole entire thing is 20, that means this inside part has to be 15. Because you already had the 5. If you feel like doing 10 squared equals 5 times 5 plus x, same sort of deal as over here. We just do our little algebra. Heck, you could even divide both sides by 5 right now. 100 divided by 5 is 20. 20 equals 5 plus x. What do you know? X is 15. Pretty cool. Chord, secant, tangent. I think you're going to like these problems. They're kind of cool. Some of them might be a little spicy, so I'll put the answer key up on Thursday, the day after, just like I did today, or on Monday to Tuesday. But this is chord, secant, tangent. Oh, and by the way, if you're worried about tangent, like you feel like tangent isn't getting any love, don't worry too much about tangent, because they're always congruent. Oh, I guess that's the rule. Hey, guess what? The rule is W equals X. So no matter what you do, they're always the same. So if you felt bad for good old tan, don't worry, because there he is. All right, thanks for watching. See you next time.